Hi, thanks for joining us today. We're going to be finishing off lesson 7-3, which is on monotonicity, one-to-one, and inverse functions. So the earlier parts of 7-3 talked about derivatives of inverse functions. Another huge application of this idea, a function would only have an inverse function, then f is one-to-one. If you don't remember what one-to-one means, one-to-one means we pass the horizontal line test. So a good example of a function that's one-to-one is our friend x cubed, something like that. Because any horizontal line I draw can only hit this guy once. Okay? Equivalently, a guy who's not one-to-one is, I don't know, sine, cosine, tangent. No. Yeah, well, all those. Because look, this horizontal line hits the graph 3 times. So that's what one-to-one means, passing the horizontal line test. And based on this example, if you pass the horizontal line test, if any horizontal line hits you only once, you must be either strictly increasing or strictly decreasing. And that's what monotonic means. That's what monotonic means. It means strictly increasing or strictly decreasing. Since f prime tells me where f is increasing or decreasing, we can use f prime to tell me where f is monotonic or one-to-one. So monotonic, one-to-one, having an inverse are all the same thing. Monotonic, one-to-one, having an inverse are all the same thing. One-to-one, monotonic, and having an inverse are all the same thing. Careful. So, how can we use f prime to tell me about monotonicity? We'll look at where is this guy increasing or decreasing. So it tells me to use f prime. I'll listen. I'm an obedient student. F prime of x. You should try to do this. 6 minus 3x squared. How could this tell me about f is increasing or decreasing? This should make you think of a test. In fact, the test, as you think about it, 3, 2, 1, the derivative test. The first derivative test, a first derivative number line. I'm going to make an f prime number line. So we should try to set this equal to 0 to find the critical numbers. Three x squared equals 6. X squared equals 2. X equals root 2 and negative root 2. So what we have is two critical numbers, negative root 2 and positive root 2. Could f prime ever be undefined? Why or why not? You should be able to answer this question by now. F prime cannot be undefined because f prime is a polynomial and they're nice functions. So that's it. Just those two critical numbers. What do we do next? We're going to test the sign here. So in the center, we have f prime is positive. We're checking the sign of f prime. Here I tested 0 mentally. Plugging f prime of 0 is 6. Over here, a number greater than root 2. It's like 2. 2 is greater than root 2. Again, I've mentioned this before. You can always use a really big number. There's no upper bound here. Use 100. Use 1,000,000. If we plug in 1,000,000, then we're going to get a negative number. Use negative 1,000,000. Negative million squared, even bigger positive number. Okay? So why does this show me that f is not 1 to 1? So I'll move it over here. I'm going to draw some guidelines. So if that's what f prime looks like, if f prime is negative, it means f was decreasing until we got to negative 2. Then f, negative root 2, sorry. Then f was increasing until we got to positive root 2. Then f decreased again. So again, that's f. Now, taking our horizontal line from before, is this guy, does it have a chance of being 1 to 1? No, because around any relative minimum or any relative maximum, we're going to hit the function twice. That's almost the definition of having a relative minimum or maximum. That if you get really close and it's a continuous function, we have to hit twice around here, even if it's the littlest relative minimum you could imagine. Okay, so that's what we're talking about. That's how this shows that f is not 1 to 1. How would I write about my ideas? How would I write this down? I would say f is not 1 to 1 since f changes from increasing to decreasing at x equals, I'm going to write this, positive root 2. Is that annoying? Okay. And that would be a good enough reason for me. If f changes from increasing to decreasing, it cannot be 1 to 1. You could have also said f changes from decreasing to increasing because f prime changes signs. These would be okay. Find the largest interval containing x equals 0 for which f is 1 to 1. So go ahead, write down an interval. Write down an interval that contains 0 where f is 1 to 1. Where f is 1 to 1. And again, that means monotonic, one tone. That's where the word monotonic comes from. Or has inverse, right? All three of these mean the same thing. Did you write down the answer? Did you write down an interval? Did you? All right. Okay, so what's one interval containing 0? All right, so on one hand, some people like to write, oh, well, negative 1 to 1. 0's in here. But could you get larger than that? Did you say negative 2 to 2? This is wrong. Negative 2 to 2 is like this, where we get parts of f that are not monotonic. So that's a bad answer. So we want a place where f is always increasing or always decreasing. That's a bad answer. But we can't go further. So, containing 0, the furthest left we can go and keep the sign at 0 is negative root 2, including, because you could get bigger if we didn't include it. And the furthest to the right we could go is positive root 2, including. Because if we go any further than that, we have to flip the sign of f prime. If we go any further than that, f would change from increasing to decreasing. So that's what we're talking about. Try to keep that idea alive with the largest interval containing x equals negative 2. 3, 2, 1. Pause the video if you haven't written anything down. Try this out. So we have 2, negative 2, is over here somewhere. We'll use gray, right? Negative 2 is right there. So what's the farthest left we can go and keep the same sign? Well, it always has the same sign on the left. So we're saying from negative infinity. When will f prime stop having the same sign? When will f stop being decreasing? It'll change signs right there. And that'd be the answer. If I got any larger than this, and I can only get larger on the right-hand side, I'd have to go to a place where f prime changed signs. I'd have to go to a place where f had switched to increasing. So again, we're looking for monotonic. That's the same as having an inverse function. That's the same as being one-to-one. All of these are synonyms. What I want you to do right now is try out, I said black. I wanted something else, a different color for once. Try problems 11 through 13. And you should be done the first part of the assignment. That's really it. Have fun with that. Finish the rest of that homework. Good luck. This is an important section. These should be easy points. This is all stuff you know how to do, just in a slightly different direction. Have fun. I'll talk to you later. Thanks for watching.